Hello. You're here with data science teacher Brandon, and we're starting our data analysis bootcamp, course one. So it's going to be an intro into data analysis, and we're going to focus on the effect of sampling has in understanding the population. We always want to understand the population. It's very hard to get that much data to get access to all of the information that we need to do that. So we often, almost always take a sample to interpret the population. And we'll understand the effect that has, and something that we just need to be aware of as we're doing our data analysis, that we are dealing with a sample, and that will have some variation, some randomness baked into it, and we need to be conscious of that as we're going through our analysis. So let's get started, and we'll get into more details as we go. So starting off, why analyze? Why do we analyze? Right? I think it's really we see our little data analyst friend here, and there's a lot of information out there in the day. So really what we want to do is we want to provide, we're working for a business normally, or even just for ourselves, we want to provide useful insights. We want to give ourselves understanding. And really the idea is that we want to support in a work setting, we want to support our business partners in making decisions. There's so much information on the internet, so much, more and more every second. They don't need that much information. They need something that's going to help them make a simple decision or difficult decision, but information that's going to support that. Okay? I think one of the things as well when we're analyzing, we want to support the decision making, but after the decision making is done, we also want to evaluate that. Did we actually move in the direction we wanted to? How did our decision go? Right? It might seem like, well, but let's actually look into it. Let's analyze it and see if see if it worked out as well as we. And so really we have just our jobs as data analysts are that there's just a massive amount of information on there, and our little data analyst friend here. You can really think of this like the internet, right? There's so much information out there that his job is really to refine down that large amount of information into kind of bite-sized little insights that your business partners can use in their decision-making process. Really crystallizing it, refining it down into useful information. Okay, so getting into a little bit more about why we analyze. So we want to understand trends and patterns. We want to understand the general trend of our industry. We want to understand the direction of the industry, because if things are changing, you need to be aware of that and adapt to them. Maybe position yourself in a better way. Maybe new markets, new industries, new sectors are opening up, and you might be able to take advantage of those. So you want to understand the general trend of your market. You also want to understand patterns, especially the repeating patterns, because if you can understand a pattern that repeats or is likely to repeat, if this always causes that, then when this happens, you might be able to position yourself, position your company in a way to take advantage of what happens next, right? So not necessarily predicting the future, but you're able to better position yourself, better take advantage of opportunities, and better prevent and position yourself, protect yourself against risks. We also want to be making data-driven decisions. I think that's kind of a keyword that lots of people say. I think we've always understood this instinctually, is that good information will support decision making. The data-driven decision is really that use of information. I think it goes a little bit deeper than making sure that we understand the current economy, the current state of our business, but we also, in this day and age where things are changing and developing so fast, I think like never before, our knowledge might be outdated, right? So we have to go back to the drawing board, going back to update our own understanding of the current situation, the current market, the current industry, and make sure we're not missing it. We want to identify opportunities and problems. I think this is more of an external thing. So we want to look outside of our business for changes in the market, changes in customer preferences. Are there different demands for different products that we could possibly take advantage of, right? So we want to look externally for things that could happen, for advantages that we could take. We also want to think about the risks that are associated with externals. Could be something as broad as the economy and understanding how changes in the economy are going to affect us. We want to be aware of anomaly situations that could be affecting our industry, maybe good or bad. Big inflows of business could be good, could really strain our business, though, could strain our operations, and then we have to spend a lot of time making that up, and really it becomes unprofitable in that situation, in a situation that we could have made a lot of money. We weren't prepared for it, so we weren't able to take advantage of that opportunity. We also want to make sure that we're identifying and evaluating our own performance, looking internally at the business, right? We want to uncover inefficiencies, bottlenecks, and really areas for improvement. I think one of the things that you always need to keep in mind with this is this could also be including new technology, which is a really valid thing that is changing very quickly, and new technology always helps us solve problems a little bit faster and complete tasks a little bit faster. So we want to look at for inefficiency, but maybe we want to look at our business and see what is outdated, what needs to be updated. Are there other ways? Are there new ways? Are there modern ways to prevent bottlenecks, create more efficiencies, and make the information, our systems flow together? Okay. So we have our little mnemonic over here. And so to start this, I wanted to ask, I know you can't respond, but just keep it in your mind. Do you know someone who is smart? Okay. So think of someone that you know, maybe a friend or a colleague, and just picture them. You don't have to share it with me. But we're just thinking of someone that is smart, or smart friend, right? So he's standing over there, and we notice that he's wearing this pattern suit as we see him, our smart friend that's saying he's wearing a pattern suit. And well, that's kind of interesting, right? And so when you picture your friend wearing this pattern, lots of patterns, designs, zigzags, lines, squares, whatever you see, he's wearing a patterned suit. And what color is his suit? Okay, so he's wearing a colored suit, and very interesting color, good choice. And so he's wearing that pattern suit to really represent that he is a fan of understanding patterns and trends. He's wearing that to really remind us that he loves to understand patterns, because if you can take advantage of those, you can better prepare your business for what's to come, and not necessarily predict the future, but forecast the future and see if you can take advantage of those opportunities. As we see, I mean, we notice all this data floating around, and he really wants to use all that data. It's just flying around his head over there, just all this crazy data. He wants to use that data to help him make data-driven decisions. Right? He's going to use that information to better prepare his business, make sure everything is up to date, make sure his own understanding is current with the current state of the world, of the economy, of the industry, that everything's up to date in terms of his understanding. As we look at him again, our friend wearing his pattern suit, his colored pattern suit, we notice that he's holding a big bag of money. That's pretty nice. And he lets us know we ask him, well, where did you get that money? He lets us know that he got it from identifying opportunities in his business. He was able to take advantage. He was able to find them outside of his business, changes in the industry, and he was able to take advantage of that and become quite profitable. He has a big bag of money. So lucky him. Okay. And we also notice when we look back at him now, we notice he's wearing these big, ridiculous glasses. They're so big. And so can I ask what color, when you see him, what color glasses is he wearing? Okay. And so he's wearing his colored glasses, and they're just, again, really big. They're kind of, even if he doesn't wear glasses, they're just really big glasses. And we're going to notice him looking down, looking almost internally. And he's wearing those big glasses to help him optimize the performance of his business, to understand the inefficiencies, if there's bottlenecks, really just looking kind of like X-ray glasses almost to understand his business and really see where there's areas for improvement. Technology, overall performance, ways to reduce costs. He sees that as a way to, or he's using his glasses to help him understand the inefficiencies and how to improve performance in his business. Okay, so moving on, some more reasons why we want to analyze. And I think this first one's pretty obvious. Usually, when you're in a business situation, you will have usually your business partner, your boss will give you a hypothesis that he wants to understand. Here's some data to understand why this happened. Right? It gives you a direction. If you go to Kaggle and you start your own data analysis, you might want to maybe get started, but you want to kind of have a direction. You don't want just to analyze everything, anything, and understand anything and everything. you'll never finish, right? I used to start like that, and it's too much. Especially with Python, we have the ability to go so deep that we need to really limit ourselves and only understand what really pertains to this problem. So we want to validate hypotheses and theories. We come up with theory. We have a theory, provided to us from our business partners, and we want to use that as a direction to run. Right? All of our analysis is going to be geared towards supporting that or understanding that problem or situation. You want to detect anomalies. And I think that makes sense, right? You want to detect things that are anomalous that could create potential risks. If you have, maybe you had a lot of business money, maybe you're selling bread or something like that. You sold a lot, you had a lot of customers, you sold all your bread today. But now you have no more yeast to make bread, right? You ran out of your supply because you didn't properly plan. Now you have to spend a lot of money getting that supply in, and you end up not making any extra money, right? You had a really good day, but you lost out on that. You didn't make any extra money from it because you were not prepared for that anomaly. So identifying anomalies, good or bad, is really important to better prepare ourselves for those situations. We want to go a little step further, though. We also want to understand why. What's the reason behind this anomaly that we want to make? Better understand, if we can understand why we have a low business, we can better understand why that's going to happen the next time and better prepare ourselves ahead of time. Okay, right? So it's really important to understand why this anomaly, if we can understand why this anomaly happened. What we want to do as well is evaluate strategies. We talked a lot about all of our data analysis stuff. We come up with a good strategy, we put it into place at this point, and we want to understand why this happened, right? We want to understand how well we did. Did we move forward? Did we move in the right direction? So common way is A/B testing. If you have a website, this page or this page converted more people, right? And so we want to analyze that, compare that, and see really if we are seeing a difference, a substantial enough difference to say it's not just random chance, right? Are we sure that this new page is working better than the old one? We want to go a little step further than that, though. So just understanding the here and now, kind of like the A/B testing, understanding this decision is really important. But we want to think of the longer term strategy of our business, right? We have many steps to get to this goal, and we make one decision, we have one step forward, but we had a bad product, we made a lot of money on it, but our customers don't want to come back because the product didn't really work very well. It's very cheap for us to make. It was not very good quality, right? So now our customers don't want to come back. So although we moved forward, one step, we moved kind of long-term strategy, and we're moving in the wrong direction. We moved away from our long-term strategy. Now we've hurt our long-term goal of being a successful business, having repeat customers. We want to evaluate our strategy here and now. We also want to evaluate our strategy in terms of our long-term strategy. And so what we have here is something weird. I used to ask students to provide me with something weird. I felt a little bit pressure to ask them for something, and in this situation as well. I can't hear what you're saying. When I'm making these images, the mnemonics for these classes, sometimes Midjourney just goes a little bit crazy and gives you some weird things. And this is one of the ones that I got by accident during this class. And so it's a rabbit wearing a spacesuit, and that's pretty weird. So right, if we wanted to understand anything really weird, anything that's different, right? Well, where do we start? Right? Where do we start with that? Well, we'd say, okay, why is this rabbit wearing a spacesuit? Come up with theory. I think he's going to fly to the moon, right? Okay, well, so, yeah, that's my first thought, right? I'm then going to direct my analysis to looking around for, is there a spaceship, right? Okay. We'd also want to understand anomalies. We want to ask her the reason why this is happening. We're seeing a rabbit in a spacesuit. That's pretty gosh darn weird, I would say. We want to ask, why is it happening? Right? Is there a reason for this happening? Maybe it's a talking rabbit. Maybe we could better prepare. Maybe we should have a rabbit catcher, and we could go sell him on the black market or something, right? If we're ready for those situations, right? Or maybe we want to borrow a space because I'd like to go to the too, and maybe if you could take me there. We really want to understand why why these things are happening, why we're seeing these things. Okay, and so as we're seeing this rabbit in that spacesuit, and if he's going to fly to the moon or not, we have our theory, and maybe he is. Maybe that is his goal, right? The long-term goal is to fly to the moon, and so we're going to evaluate his strategy. Okay, we see a rabbit wearing a spacesuit. That's great, and does that move him towards his long-term goal? Right? Yeah, wearing a spacesuit is good. You're one step closer to getting to the moon. But as we look around, there's no spaceship anywhere, and so kind of doing things out of order. But you gotta, get your spaceship first. You gotta figure out how to get there, and then put on your spacesuit, right? So it's kind of not really thinking of the long-term strategy. You put on a spacesuit, you're gonna wear that for a couple 100 years while he saves up the money to get a spaceship. And so he's not really thinking, he's not really moving himself in the right direction. He should be going, looking for a job, putting on that spacesuit. I don't know who's going to hire a spacesuit, but probably not going to help him in that sense either. So we really want to be evaluating our strategy, kind of the here and now, and the long-term sequence of that. Okay, so talking about populations and samples. So it's really just important to understand this concept. It's part of all of our data analysis. In every set of data, this is going to be a factor. It's not like a characteristic in our data set. It's kind of behind the scenes, but it's there, right? So we need to understand how the sampling process affects our understanding of the population. So we never have access to the population. We always want to understand the population. We're trying to make decisions based on the population as a whole. How can we offer them a better product, better service? But we don't have them. We don't have access. We only have access to customers or a certain region, but we want to understand more. Okay? So we need to understand that our data, and just keep in mind, keep it in the back of our head as we're doing analysis, it's a sample, right? And that's going to affect our understanding or what we can understand from our data. So that was, remember that point. Imagine a time. Well, have you ever seen penguins, or not penguins, pandas at the zoo? Okay, and so if you've never seen pandas, imagine a bear's environment or another large animal the last time you were at the zoo. So as we're standing outside the panda's environment, we're looking at that, and one of the things is we see this panda in here in this big environment right there, and then all of a sudden, out of nowhere, illogically, pandas are just falling from the sky. Right? And there's so many pandas, they're filling up this environment, right? A big mountain of pandas now, right? And the important thing to remember though is this is still just a small sample of the pandas. It looks like a massive amount of pandas, a giant mountain of pandas in the panda environment, but it's still just a small sample. That's one of the things. Even 1 million rows, 2 million rows might still be a very small sample. We need to keep that in mind as we're doing our analysis and how that will affect our final answers and the robustness of the things that we're seeing. Okay. Okay. So there are many different ways that we can take a sample, collect a sample, and I feel like this really comes down to a cost versus money thing. If we had all the money in the world, we'd go do a survey, we'd ask everyone in the world. We'd probably need all the money in the world to accomplish that, but we would be able to. That is just really, really expensive to do. So kind of the best alternative would be a simple random sample. We just want to analyze. We want to get a good, diverse sample. There's no bias. We're not randomly selecting more of one type than the other. We're getting a really diverse, a truly random sample population. So as we go through these different samples, let's think about, we have our different pandas right here, and they will, as we do these different sampling techniques, we can kind of visualize and think about how we might be collecting or we might be missing some. We got lots of black pandas, a blue panda, a white panda, a red panda, an orange panda. How is that going to, are we going to get a truly diverse sample as we start selecting these, using these different sampling techniques? And again, it's really cost versus money, time versus resources, and what's possible. So another type of sample is a stratified sample. I think this might be a good example of this is a telephone survey. You're going to call 10 people in every city. You're going to randomly select them and just go through this. And that's very reasonable. Another one is a cluster sample. I think this would be limited on a physical location, right? You'd only be able to sample everyone in a certain area. And that would be if you're doing a door-to-door survey, you would go door-to-door. You might as well just see everyone in that neighborhood while you're there. And so you're going to get everyone in that, well, hopefully everyone in that neighborhood as you go to your clustering. So everyone try to get different diverse neighborhoods, but that are still, you're going to try and get everyone in that neighborhood. And a multi-stage sample might be more on a global scale. If you think that you're just going to survey people maybe in a certain country, right? There might be some countries that you're not able to get access to, that are not safe to go to, that are not possible to speak different languages, just might not possible to get every country, so you focus on certain countries, and you try to do random sampling inside each of the clusters that you've set, the countries that you've set, in terms of what you want. So thinking about how these will change, really what we want to do is, as we're collecting these, we want to minimize the bias. We want to make sure that we are, as best we can, collecting a truly random sample for the money and the resources, the time that we have available. I think the time that information becomes data is when we organize it, we give it structure, we give it format, in this sense, right? Still information, but now it's called data when we have it organized in a computer-friendly format so that we can really unlock just a huge amount of power that was hidden for a long time until we realized that we can organize things in the terms of the computer. We can really do a lot more with our information. So we have a data matrix is a square shape. Pandas data frame is the same thing, square shape. Right here we have the columns and we have the index. The important thing here is that this allows us to access either column or row, but also to access any data point with the column, kind of the coordinates of where each data point is. And this allows us to find the data, do lots of things with it, play around with the data and all those things. Okay. So pandas data frame is what we're going to use, and really a pandas data frame gives our data structure. This data matrix gives our data structure, our information structure, and that is when I feel like we can call it data. And just like the pandas data frame gives our data structure, our data over here is giving our panda structure. Okay. Talking about types of variables. This honestly is it's so easy that it seems that you don't need to pay attention to this, but the more advanced you get with Python, the more data types become important. It's really kind of a subtle way that you communicate with Python. Your code is directly how you communicate, but your objects, the way that you communicate, Python knows what to do with each object because of its data types. So by understanding your data types, making sure that things are not changing, they are what they think they are, even the difference between an integer and a floating or a decimal point number can have a slight effect. And so data types are something we need to communicate with because that is what lets Python know what can be done with any given object. And so it's really how we're kind of communicating on a subtle way with Python about what can be done with things. We really have to pay attention to this. We have major types of categorical variables, things like man, woman, dog, cat. And then we have numerical, which are kind of straightforward, age, the average, and we can do certain things with that. Very easy to do numerical calculations on numerical values. Data science and lots of things that we have available will allow us to use categorical variables in a way that was not necessarily able to be used previously. So very good. And looking at our two little panda friends here, you will notice they're representing the data types here. So we have the numbers to help us remember the numbers, but also the black and blue pandas to help us remember the categorical data types, so numeric and categorical data types. Okay, getting into subtypes of variables, we have our major types, numerical and categorical, but we can break those down a little bit further. As numerical, we have distinct, which is more similar to whole numbers, 1, 2, 3, 4, and continuous are the decimal point numbers. Negative infinity to positive infinity in every decimal point place. So 0.001, 0.002, and everything in between. Okay. Categorical variables, we have unordered or ordinal types of categoricals. This is kind of subtle, but it becomes very important in our analysis, in machine learning, and how we're going to use these variables. So unordered would be dog, cat. I like cats. I'm a big fan of cats. I would say that cats are better, but can you really rank them as cats are better than the other one? Not really. They're just different. They're just two different species of animals. You might like dogs or cats better, but they're still just different, right? So they're unordered in that sense. They're just different things. They're categories, but there's no ranking system to them. The other way would be small, medium, and large, or ordinal values in the sense that we have a ranking system. So small, medium, and large, and we could do things with small, medium, and large. We can convert that to 1, 2, 3, and do things like a correlation analysis now against this categorical variable. And there's lots of different orders. The way you analyze these in data analysis will be different. The way that you deal with them in machine learning will be very different. So we'll have to pay attention and really have a good understanding. It's not complicated, but we need to understand what our categorical, what the classes in our category mean. Okay, going through the recap of our mnemonics in this class. So we first talked about how a data analyst job, really in simplest terms, is to reduce down to refine all of the information that's out there on the internet, all the information that he has access to, the data that he has access to, down to bite-size little insights that he can support his companies or his business partners, his boss, their decision-making process, and really make it a lot easier for them instead of then going through all of the internet to find out the answers. He can really reduce it down. Talked about our smart friend that was wearing the pattern suit to help us remember about really understanding patterns and trends is important. He also had all that data floating around him to help us remember that he wanted to make data-driven decisions. He was holding that big bag of money as well that he got from identifying all of those opportunities outside of his business. And he was wearing those really big, ridiculous glasses, if you remember, that he used to look kind of introspectively and really optimize the internal operations of his company. Over here, we had our rabbit in a spacesuit, which a very weird thing for sure. And so if we see something that's weird, something we want to understand, we should start with a hypothesis and ask, what is he trying to do? Well, I think he's trying to fly somewhere. I think he's going to the moon, and that would lead us to start looking for the spaceship. So it gives us a direction to start our analysis. We also really want to understand anomalies, but we really want to understand them, not just that they happen, not just that there is a rabbit in a spacesuit, but really ask why that happened. Why could that be? Where did he get a rabbit? Where did he get a spacesuit that fits a rabbit? Why is this happening? Right? Really understand the anomalies on a deeper level so that we can take advantage and better prepare for the anomalies that happen on the downside, but also take advantage of the anomalies that happen on the upside. And as we talked about, we put a lot of strategies in place, and we wanted to make sure that we're always evaluating the strategies. So does the rabbit wearing a spacesuit move him in the direction of flying to space, or is it just a crazy rabbit in a spacesuit that does not have any spacesuit, right? So is this really moving him towards his final goal? Okay, we want to pay attention to that and evaluate our strategies after we put them in place. We talked about the different random sampling techniques, and just important to think about as we talked about the random sample, the multi-stage, the clustering, how each one of those different types of sampling techniques is going to affect the sample that we get, the diversity between how many blue pandas, how many white pandas, how many black pandas, how many red, orange, and golden colored pandas do we get, right? Are we getting a diverse grouping that matches our population? And each one of those will always be a cost versus benefit. Love to get everyone in our sample, but that's not possible. Especially for it's not possible for the cost that we would incur. We also talked about important to remember that we always have a sample, right? We always have, regardless of how big we remember we're standing outside of our pandas environment at the zoo, and we saw all those pandas falling from the sky, the big mountain of pandas, and that still though was still just a small sample of all the pandas out there. So we just need to keep in mind that we are dealing with a sample, and that will have an effect on the robustness of the answers we can extract from our data. We briefly touched on what a data frame is and how information gets transformed into data once it's really given structure, right? Given that data frame, that square format of columns and indexes to allow us to access our data. And just like a data frame gives our information structure, this data right here is giving our panda structure. Okay. We talked about different data types. We have numeric and we have categorical, just like our pandas supporting the numbers, and the black and blue pandas supporting the categorical data types. We briefly touched on relationships in our data. We're going to cover this a lot more later on. But really, we want to remember, getting back to think of that hypothesis, we really want to have a hypothesis that guides our analysis. Which relationships are going to be important for us to understand? We could understand all of them. There's a lot, right? So we need to be focused when we're looking at our relationships, but we want to understand them on a deeper level as well. We want to not just look at the correlation to start. Correlation is great. Correlation is normally where we start. we often want to go a little bit deeper than that and look at things with a simple visual inspection and really see if there are other patterns, if there are other clusters, if there are other things going on that we would want to understand that could be affecting the simple correlation metric. So in this class, we used a lot of mnemonics. The pictures were a little bit unique. Hopefully they're a little bit illogical and a little bit weird, but that was the point. I know this is not your classical university style of class, but the idea is that this information is hopefully going to stay with you a lot longer than it would listening to a professor at a university talk. Okay, right? The goal of this was to help block this information in your head. I used unique, illogical, and I used colors to connect things as well. I also created connections to your past memories. So someone you know, the time you're at the environment of the pandas at the zoo. And I also created a story with some of the pictures as well. Some of the points that we talked, there was a story there. So you can use those points to connect and they connect together. Our memories work by connection. So we want to create as many connections to a memory as possible to help us remember. Not just reading something over and over again. We want to essentially attach it to another memory so that we have a path back to that and we can remember that. Use location a little bit. We talked about the size of the pandas. Our friend was standing over there. It really, our minds work in a better way that helps, that works with location. So the more that we can think of 3D spaces, it is a little bit easier for our minds to remember those things. Okay. And your job from here is that would be good for you to go through. As you saw, I didn't read the slides. There's a lot of extra information in these slides, so it'd be great for you to go back and read the slides. The download is at the very top of the class. It would be good if you went through and read all of these things that apply to our class, and you can just review it. Make sure that and as you attach them to the pictures, you'll have the picture, you'll have a little bit more information, and you'll build on that as you continue to practice and build your Python skills. You'll now hopefully have access to all of the things that we learned in this class. And it shouldn't feel like you have access to it. It should just be there. You shouldn't, I think if you pay attention to it, you'll notice that you don't have to fight to get that information out of your brain like you would at a university or a classical high school class that makes you just read through a textbook over and over again. This should just feel easier. It shouldn't feel that it's hard. It shouldn't just be like, oh, this is easy to access. It will just not feel that fighting to get back to that memory that happens with traditional education. Um, so yeah, so thank you so much for joining me. I look forward to seeing you in the bootcamp number 2. Hello, and thank you for joining me for the Python part of our first data analysis bootcamp. Really, this is just an intro to Python data analysis. I'll make available the data set for this class. This is just a penguins data set, and we're going to go through here. So we have our data set here. We have our standard, and here we have our standard data science libraries: pandas, Seaborn, matplotlib, and numpy. Importing the data from my GitHub reservoir and looking at the data just to get started. We have a few different species, islands. We have the different lengths and statistics of our penguins, and we have their gender, male. We have 344 rows and 7 columns. Looking at the dot shape, an attribute here. So when we look at that, are there any null information in our data set? So we run df.isNull. To show you what df.isNull does, it creates a matrix, a data matrix of a data frame of trues and false values. We use sum, by default, it goes across the column, so it's going to sum up all of the values. Falses are equal to 0, trues are equal to 1, so we're able to sum up all of the true values, the times that it is null, and get a good sense of how quickly or how many null values we have in our data set. And you can see here, we got a few, not too many. A good idea is always to look at the .info. Data types are just so important. They affect many of your statistics, and we really want to understand what they are so that we don't run into problems in our later analyses. Python, kind of a sub way that we communicate with Python is the data type. So we really need to make sure that we understand them to prevent us from running into errors and to make sure that Python understands what we're trying to do at each step of the way. So to kind of, for this class, I really wanted to highlight the effect of taking a sample, concentrating on that sample. So we have 344 rows in our data set. So if we look, I looked up on the internet and there's roughly 20 million penguins in Antarctica. Okay, so that's a lot. So we got a sample of 344. That fill up that pandas environment, no problem. Lots of penguins, but still just a very small sample. To kind of simulate the effect of taking a sample, what I wanted to do, this is only a fraction of a percent, a very small fraction of a percent, but what I wanted to do is take 2%, just as an example. So if we take 2% from our data set, and we'll pretend that our data frame is like the full population of pandas, and the sample that we take is the collection of our data set that we took today. So if we take 2% of our data set, that's only 6 rows today, but that will work for our evaluations and to understand how much our data can change just by taking a sample. That's really important to keep to heart. It's just that our data set, the statistics we get are going to change, are going to be different than the population. So we need to understand that variation that's created through the random sampling process. Okay. If we wanted to take the mean of a column, what we do is df column name dot mean, and we can get the average mass. We want to take the mean of all columns at once, we can go to df dot mean and take a look here and to show you what that looks like. Do sample one dot mean right here. What we're going to do is we're going to see the mean of the bill length, the mean of the bill depth, and each numeric column. Okay. What I did here before I took that sample one, what I do is df dot sample and sample size. So sample size is up here, it's the 6. So we're getting 6 rows. And what we can do is just to see then how much the mean is changing by each one of these columns. You can see changes quite a bit sometimes. So bill is 40, 45, 42, quite a bit. But let's look at all those together so we can actually make a comparison. Here I'm going to use pd.concat, use a list of the data that we want to put together. So we're going to go mean sample, mean 3, or sample 3 mean. And cross the axis once. I'm going to stick them together horizontally. And the next row, all I'm doing is putting the column names. So change the column names. If we didn't do this, we'd see 0, 1, 2, 3. So not super helpful, but if we can give the column names a little bit clearer for our end user to be able to. Okay. So let's create one sample. Let's do it 50 times and really start to get a sense of this variation that we're getting. So we can see that there's a lot of variation here, quite a bit in the bill length, a little bit less in the bill depth, but let's really start to understand this variation that's caused through the resampling process. Okay, so I'm going to create a blank data frame. A classic for loop syntax is to create a blank list before you go into your for loop. And so here we're doing with a data frame, we're going to create a blank data frame that we're going to fill up as we go through our loop. It's a little bit different than the list, but it works very much the same. Okay. So we're going to go for, I'm going underscore. The reason I put an underscore here is because I don't intend to use the iterable variable in my loop. So I'm just going to say blank because I'm not really using it in this one. So for blank in range 50. So I'm going to creating a list of 50 values. I'm just going to be repeating this 50 times. We get a sample of my sample size 50 times. I'm going to take the mean 50 times. And I'm going to stick it into my df means data frame 50 times. Get a sense. And so you see all these errors. It's not necessarily something we need to know today. I've seen this many times. It kind of gets a little bit boring. So if I didn't want to see that every time, the way that we can turn off our warnings is we go import warnings. It's letting you know about something in the future. It's going to be changing. Good to know. You don't need to see it every time, right? So import warnings, warnings.simple filter, and just ignore, right? So we turn these off. If I were to run this again up above, you'll see. There we go. No more warnings. Makes it a nice cleaner workbook for us to share. So because we were sticking things together horizontally, we have 4 rows and 50 columns. So just to get them in the sense so that we can plot this and work with the data like a typical data frame, when our column names at the top, we can just go .t and tilt our data frame 90 degrees like we have. And so it's good. Let's actually just save that like that so that I can use it, work with it when we do our plotting in the next stage. So here what I'm doing is df means. I'm just saving it as this tilted wedge. So what I'll do then is space here. So sns.hisplot data equals df means, and then x equals bill. I'm going to get the population mean from the original data frame all of our population, the whole 20 million, our simulation, 344 samples that we're using to simulate the 20 million population of penguins in Antarctica. Okay. Here, what we're doing is we're going to take min. So we're going to, sorry, let's go step by step. And then what I do is I plot a vertical line of the mean of the population. So you can see we are centered, our data is centered around that. And then what I'm going to do is I wanted to understand what the confidence, one of the things about this resampling is we can build confidence intervals. So we know our population is this, but we wouldn't know that if we were just taking a sample. We would have to resample this, and we could get a sense that our data is in a certain population average is in a certain range. And by this resampling process, we're simulating it essentially. So we'll be able to say, if I want to get the NumPy percentile, the 5th percentile to the 95th percentile, I can get a sense of how much data falls within that 95 percentile. Okay. And so every time I run this, it's going to be a little bit different. So if I were to rerun this sample here, the loop up the top, I will get a slightly different sample. This is a resample. Make sure I tilt it again this way, and so it's going to be different every time. And now we have, just noticing at the bottom, our confidence interval where we could be 95% population mean is between 40.23 and 47. So although our average is right here, we're confident that our true average is in this range, not this full range right here, but 40 to 47. I'm going to do the same thing with build depth here. And again, we have our average, we're 95% confidence in 5 to 18. And then looking at our confidence interval of flipper length, again, 199 to 210, so a bigger range here. And confidence interval for our body mass. You can see it's centered around where the population center is, but that doesn't really mean, because we may sometimes get a sample down here. And so if we got the sample right here, we need to understand how much, or have a good sense of how much variation there can be collected just in the collection process that's created. We don't really have access to this statistic of randomness in our data frame, but it's there. It's kind of, it was created in the collection process, the sampling process. It's just not visible. So we just need to understand that it's there, and this is going to highly affect how we interpret our results and the understanding that we can take away from our mean, our correlation that we are understanding in our data analysis. It's really crucial and important. To think about stratified resampling, we'll get a lot more into Seaborn and how to use all the cool little things that we have access to with Seaborn. Yeah, one of the main reasons that you, well, not main reasons, but a really powerful thing that we have access to in Seaborn is this hue argument. It's going to change the color of our distribution by the color of the gender, or sorry, by the gender. Okay, so male and female here. Here. So this is a quick little way to view the hue, kind of stratified resampling done on the spot, but not exactly really well. This is just splitting the data frame into color coordinating our data frame or our distribution. Let's actually do a resampling process and see if we can get a better understanding of this. So here what I'm doing is when I create a female distribution, I'm going to do the gender of the female column, or the gender, the sex is equal to female. And what this does, if you run this, this creates a true and false Boolean column. And if we use that in the first square brackets after our data frame, we can select just those rows that were equal to true. Same thing for female and male, and we get then 165 and 168. Here what I'm doing is I'm doing the same loop that I did up above. I'm doing for two data frames now. So female and male. And what I'm going to do is I'm going to sample for female, sample for male, get the mean for the female, get the mean for the male, and I'm going to concat those both into the blank data frames that I had up above, and then do that 50 times over, just like we did up above. Do the same thing here where I flip these a little bit on 90 degrees, just so they're a little bit more data friendly, and we have our column titles at the top. Okay, so I'm going to plot the histogram of the males, histogram of the females data frame of the same data set. And then what I'm going to get is the confidence interval for the female, or sorry, the males, and then the confidence interval for the min and the max percentiles. And then I'm plotting it out right here. And just to know, I just kind of skipped over this, but so I'm putting the min here, what I'm doing with this little, I'm doing an F string right here. And that allows me to put a variable into my string and not just print out the word min, print out what's inside. And then this colon dot 2 is saying 2 decimal places, a floating point number with 2 decimal places. Okay, so this cleans it up. If you don't do this, you get a really long number. So this gives us a sense here. So if we see now on the male population is 42, the mean is between 42 and 49. The female population is between 38 and 45. As we can see, there's just a lot of overlap. So it really couldn't be any sure in any real sense that these are not from the same. Maybe a little bit confident here, but there's still a good amount of overlap. There are some outliers here with the female that are way over here to the left, but so maybe there's the chance, but really you can see that because the confidence intervals are not significantly, but overlapping with a good range, that we would have to be a little bit skeptical. Would have to be a little have to be a little skeptical that there is really a difference between the male and the female population. It's very likely, but we're still not 100%. We couldn't statistically prove, but we can still get a better sense than just does it pass a hypothesis test. And we'll come to that in a later class. Okay, and so looking at here, we're seeing now the build depth. And you can see here, we have the min is 15 for male and the max is 19 for the confidence interval and the female. Again, we have quite a bit of overlap in this one. You can see here, and that's really amplified here. There's really some outliers in this female population right here, but the bulk of the female population seems to be very highly overrated. So, and this is a good point, even where the population is, or even where the confidence intervals are not exactly significantly, they're kind of half and half overlap. I think seeing this sampling gives us, visualizing the sampling process gives us so much more detail than just a simple confidence interval or even a hypothesis test. A p-value of 0.05, but what's the p-value of 0.06? What does that really mean? Okay. And this is a good way to see this. You can see that, oh yeah, well, we don't have that much overlap. Really, we can see that the bulk of the female population is really sitting on top of where the male population would be. This gave us some insights into how confident we should be in the difference. And I would say here, I would say very unlikely that we would be confident, but there's also an interesting cluster or something of the female population that would be worthwhile to explore a little bit. Okay, and going here. So doing the same thing now for flipper length here and taking this, and we have 96 and 89. So it is, again, it's a lot of overlap, but you can see here now lots of the female population is over here on the left, not so much in the range that's overlapping. There still is a good amount of range, but getting a little bit deeper understanding of this sampling and how much it would affect our population, how much the range could change. We might sometimes get a female average height here and a male average height here, but lots of the time we'd expect it to be the same. But we know they're still not exactly the same. As we look at this, we can still see there's a substantial difference between these two populations. And then looking at, we have here the body mass, getting a good sense here. Really, there is just so little overlap here, only goes to 44 is the minimum, and the maximum is 4,300 here. So it does say that they go over a lot, but you can see here there's a little skinny tail. It's not super skinny, but it goes to kind of little tail where they overlap. So for this one, I would be very confident that we would expect to see a female that is much smaller than a male. And we know kind of how mammals work, I guess. That's not super surprising, so we would expect to see that, but it can be something that we need to be aware of. I shouldn't say mammals, we should be aware of birds. Generally, the males are bigger, and we really want to see, but this tail that sometimes crosses into it, it's not really a bulking, it's not like a normal distribution, it's a little tail that crosses into this. And so you can get a better understanding of what are the chances that we would expect to see. Okay, and here you see direct features have associations. So we're looking at correlation. You see a correlation matrix here, and we're able to quickly tell if the bill length in millimeters has a correlation with the build depth, and we see the build length has a correlation of 1 with itself. It's perfectly correlated with build depth. It has negative 23. Flipper length, build length has positive 65 and then a positive 95% with mass and we get a sense of what the relationship is to the feature. So as I said, we can expect these on a deeper level, and a good start is just with the scatter plot. So the way we do this very easily with the pandas plotting function is df.plot kind equals scatter, x equals bill length, y equals flipper length, title equals, and put a really handy feature about pandas is we can put our title right into the plot, very quick and easy, and we can also change the figure size. A little bit more difficult in Seaborn, not difficult in a sense, it takes a little tiny bit more work to do in Seaborn. And getting a sense of the correlation, and you can see here there is a lot more going on between these two variables here than just there is a negative correlation between build depth, and flipper build depth, build depth and flipper length. Sorry. And so looking at the correlation, so you can see there's a lot more going on between this correlation. If we look at the correlation, it's a negative 0.58 correlation. So you can see this shows a negative correlation here. And so there's obviously a lot more going on here. This looks like there's two clusters or something. So it'd be something worthwhile to inspect. So now looking at the proportion of each penguin living on each island. And so a quick way to do this, really what I need to do is I need to count, just really from one column, I need to count it each time they're from each column. So what I'm going to do is I'm going to go df.group by island and species. Okay, so I'm going to group by island and then species to get a sense of the island and the species living on each island. Okay, I only really actually care about one of these columns. So I'm just actually going to be selecting from this data frame that's created in the group by value. I'm going to select just the sex column, really I picked just one of them. I'm going to create a pie chart. So generally in data science, they have kind of a not strong love for the pie plot. And that's because our eyes just are specifically not good at seeing the proportional difference. We can tell one's bigger than the other, but we have and it's just our eyes have a very hard time at telling the exact amount of how much one is bigger or small. So you can see here 13% here, 14%, that would be very hard to see. The answer to really make this a little bit more usable is to note our plot right here and really put the percentages right here, make it a little bit easier for us to read and really understand that the purple is, although only a little bit big, not even a full percentage, it is bigger. Okay. I think we could do a little bit more to kind of highlight. I think some cool things that we can do in the pie plot is we can explode one of the layers. So I'm going to say I want this one to be separated by 15.15 versus 5, 5 or 0.05, 0.05 here. Gives it a little bit of spacing and really steps it up a little bit. So just to show that we can do that, a little fun with the pie plot, and we have a little bit more fun. Okay, so I think this looks a lot better if we add just a little bit of extra detail to this and really adding a black line. Plotting in pandas or in Python in general it's easy to do. To do the formatting, the details can be a little bit more work than you would expect, but it's really great practice doing some more higher level Python techniques right where we can see them happening. We can see the results of our Python coding in the moment, and we can have a lot of fun with this while we're practicing more complex things in Python while we're doing our data analysis. So this is a great way to practice some more complex things in Python, and we'll see a whole bunch more examples as we go through this. What I'm doing right here, I'm doing the same thing that we saw right above, and I'm just going to save this as an object. So it's typically called AX. In the next line, what I'm going to do is for W in ax.patches. This creates a list of all of the wedges, the parts of my plot. So this patches is showing us the list of the items in our plot. I'm going to go W, so wedge dot set with line width, and then set edge color to black. Put a title on this way. This way I can add a little bit of space before and after. I can change the font size, and I can make the title bold versus doing the title right in pandas font. A little bit more powerful. Notice that I'm doing this with PLT, so matplotlib. Pandas is made with matplotlib, so it is meant to kind of work this way, that we can do this, we can call this on a pandas plot, because pandas really is matplotlib. So if we want to do some extra formatting, we'll often need to use PLT matplotlib to do so. Okay, I'm just turning off the label on the left-hand side as well. And we get a nice little plot here. It looks quite nice. And it adds a little bit of texture. Some people still don't love the pie plot, but I think this really highlights, if we wanted to say focus on our presentation, focus on the animals from the Biscoe and then the Adelaide, this group right here, and really talk about 13%. Maybe we go on to the next slide and we highlight a different section. Really powerful little technique, something really cool that you're not able easily to do outside of Python. So thank you so much for joining me for our first data analysis bootcamp, and I will see you in the second.